This video file is recorded in Sabancı University during the recitations for the CS201 Introduction to Computing course, as it was given in the fall 2016 semester.
Well, good morning again. This is the 9th week of CS201. We're going to cover some examples about programming games, but it will be at the third lecture. And in the first lecture, we are going to see some randomness because you're going to need some random stuff for your homework. Okay? Basically, we are going to talk again about the random generator class we talked last week. I send you on email. You should have on email today's codes. There are some slight changes there. So before starting, maybe during the first lecture, we are going to do only one example. We are going to repeat the random generator class, and afterwards we are going to solve more examples during the second hour and the third lecture. We are going to cover basically some gaming stuff. The robot stuff is going to be more advanced. You'll see about that. Okay, so please download your codes that I sent to you. Let's start with random generator example. Just copy paste all of them. I'm selecting them all, copying them. I'm pasting them and add an existing item, basically add all of them. The header file is usually here. So again, let's go and talk about the random generator class very briefly, what it is about. This is the random generator class. So I'm going to write it. So class random generator. I'm briefly repeating it for those that were absent last week. What do we have inside? We have as a private data our initialized, it's a kind of seed, because with this class we are trying to generate random numbers. And when you try to generate random numbers, you usually need seed. Seed means you can take your name, surname, concatenate them, time, whatever, do some calculations and come up with a random number. The most important functions here are those public, those are all of them public functions, member functions, like random integer, and it returns an integer between 0 and max. Basically, max is given as a parameter. So this is from 0 to max. Max is given as a parameter. We have another random integer function, but it takes low and max. It takes two integer parameters, and this function returns a random number between low and max. Okay? We are also dealing with real numbers, so RandReal. It doesn't take any parameter, and it returns a real number between 0 and 1. I think it's inclusive. Also, we can return a real number between low and max. We are returning basically, as you can see, double numbers. And here we are returning integer numbers. All of them are random. You should know how to use those functions. I don't think that we are going to use we are not going to generate random real numbers. We are going usually to generate random integer numbers. Okay, so this was our random generator class. What are we trying to do here is the following. Let's play a game together. I'm going to write a number here. I'm going to hide it from you. You didn't see it? And I want you to guess it. Okay, but I want you to concentrate here. Are you here? Can I have your attention, please? Okay. So, our job is the following. From 0 to 100, I want you to find the guess. I wrote the number on board. You cannot see it right now. And the game will be the following. You will give me your clue, your guess, and I'll say it's bigger or smaller, okay? And let's see how many attempts you need to find that particular number, okay? So I'm randomly generating a number between 0 and 100. Okay, give me a clue. Very nice. 50. Okay, so your friend, so this is from 0 to 100, and 50 is here somewhere. And I'm saying, no, it's not 50, it's greater than 50. So, you used one guess. It's not 50, but nice one. It's greater. Another guess, come on. Very nice, 75. You're getting the logics, basically. No, it's not 75, but it's smaller than 75. 60. It's an integer number. So? 63. Yeah, 63 might do it. Let's say 63 is here somewhere. I'm saying no. It's not, but it's greater. So this is your third attempt. 69. 69 should be here somewhere, let's say. And I'm saying it's still greater.
72.
72 should be here somewhere. I'm writing it here, and I'm saying no, it's greater still.
74.
Well, this is your fifth attempt. 74 is here somewhere, and I'm saying it's smaller than that.
Come on.
Yeah, no. 73. 1, 2, 3, 4, 5, 6. If you don't trust me, yeah, 73 is the number. Here is 73. Okay? Yeah. But come on, I mean, you did it in 6 guesses. Do you think it's good? I mean, from 0 to 100, you did it with 6 guesses. Is this okay or not?
It's too much.
It's kind of too much. Yeah. And we will see why in a while. Yeah, you are right, because of the way the game was planned. Yeah, it's a kind of not too much, but a kind of too much. So let's come out with a formula. I mean, with 100, how many guesses you expect on average in order to be almost sure that you're going to give the right guess if we do the following thing. How many guesses you should expect? Can you come up with a formula? So I'm going to do something, and it's very important for you as future engineers, especially for the engineers. When you write programs, you should somehow link the input with the output. You should come out with a formula, mathematical formula about this stuff. And this is one of the ways you can do it. Let's start with something like this. So, we did it with 6 guesses. And let's say, I'm saying the following, I'm telling the following stuff. So, this is the range, the maximum range, meaning here maximum was 100. If I say, well, let's find number not from 0 to 100, from 1 to 100. I'm saying, let's find numbers from 1 to 1. How many guesses do you need for this stuff? This is number of guesses. We are going to write it as n. So I'm picking a random number between 1 and 1. How many guesses do you need? 1. You don't need the guess, because it's for sure 1. So it's... Oh, the guess is 1. If you say that, yeah. The guess is 1. But where I'm asking about the number of guesses, and I'm writing it's an n, it's 0. We don't need it. Very nice. So the maximum here was 1. What about this stuff here, from 1 to 2? How many guesses do you need to find? 1, because I'm going to, remember the game. You give a guess, and I'm saying smaller or bigger than that. So if you find it with your first guess, okay, so number of guesses meaning like maximum number of guesses, okay? So if you find it with your first guess, it's okay. But if I say it's from 1 to 2, and let's say I picked 1, and you say 2, and I say no, it's smaller, of course it's going to be 2. So you need only one guess. The second guess is obvious. What about from 1 to 4? What do you think? How many guesses do we need? So let me help you. This is 1, 2, 3, 4. And you give a guess. Let's say you say I'm picking 3, but you don't know it, and you say 2. Okay. And when I say 2, and you say 2, and I say no, it's higher than that. So one guess was used here. Between 2 and 4, how many guesses you are going to use? I mean, not between 2 and 4, between 3 and 4, how many more guesses do you need? One more. So one more was used for these 2, and one more for 3 and for 4. We need 2 guesses. Okay, so remember, when the maximum is 2, we need 1 guess. When the maximum is 4, from 1 to 4, we need 2 guesses. What about 8? From 1 to 8. Again, let's write this stuff here. So this is 1, let's say 4 is here, and 8 is here. Probably you're going to say 4. Okay, and I say, it's smaller than 4. So one guess was used. Between 1 and 4, how many more guesses do we need? We need 2. Plus 1 that we wasted for this 4, we need 3. Okay? 116, what do you think?
4.
It's going to be 4. 132, it's going to be, you are expecting 5 guesses. I'm going to erase this stuff here. Okay, let me write here. I'm going to erase this stuff here. So, between 1 and 64, how many guesses do you need? 6. And I'm not going to go more than 128. You'll need 7 guesses. Okay. Can we come up with a formula between the maximum range, between the range? When I say the range, I mean the maximum, this guy on the right, and the number of guesses. We are writing number of guesses as n. Between max range and n.
2 to the power of n.
2 to the power of n. So, very nice. Range, how are we going to write? Okay, max range. You see, it's 2 to the power of n. Because when we have 1, 2 to the power of 0 is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. And so on. So max range is equal to 2 to the power of n, when n are the guesses. And the problem is the following. Usually, when I came here and I said, okay, let's find a random number from 1 to 100, we know the range, and we should find the average number of guesses. So, how much is n?
0. 1.
What do you think, 0? 1 and 1?
0 to 1.
2 to the power of 0 is 1. 0 to 1, it's 2 guesses. I mean, this is the maximum range. I mean, how many numbers? Numbers in range, better, not maximum range, numbers in range. Numbers in range, if you want. Okay. So numbers in range. We can start from 1,000 to 1,100. We have 100 numbers in range, 101 actually. So if we know numbers in range, how are we going to find the number of guesses? Come on. So if this is exponential, and what's the inverse of the exponential? It's logarithm, yeah. So n is logarithm with base 2 of numbers in range. But hey, this is our formula. Okay. But there is a problem, kind of. We saw that we can find that what's the logarithm with base 2 of 64? 6. But what if I say logarithm of 70?
Yeah.
It's not going to be an integer number. So the formula is going to be the same, but I cannot say, okay, you need, if let's say the logarithm of 100 is 6.3, I'm not going to say you should make 7.3 guesses, okay? Because you don't have half of or 0.3 guesses. That's why we are going to use the ceiling function. You know what is this? If you don't know what the ceiling function is, just let me remind you that 6.3, it takes the biggest integer, which is closer to this number. So it's 7. And the floor function is this one. It's written like this. Okay? So ceiling and floor. We're using here the ceiling function. So this is the formula. Okay. Now our job will be to program all of this stuff. We are going to randomly find a number from 1 to 100, and we're going to guess that number, okay? Let me run the code first. And now you see why. So from 1 to 100, so the logarithm of 100 with base 2 is kind of like 6 point something. We're going to round it to 7. Okay? So this is our program. I'm going to run it. I'm going to explain it afterwards line by line. Well, let's see what it's doing, and later on we will see how it is doing that stuff. So, I know a number between 1 and 100. Can you guess it? So we have 100 numbers. So what would be the best guess? Always you will start with the middle, okay? Let's say I'm saying 50. Bigger, please. Then where I'm going to do the same thing you did with 75. Bigger, please. What?
82.
82? Let's do with 82. Less, please. What? 78. Congratulations. So we 1, 2, 3. With 4 guesses, we found the number. Okay? But we are kind of lucky, because if we use 7 guesses, we would find it for sure. Of course, the guesses that we are making are kind of smart guesses, because when I'm trying to guess a number, I don't give 99 as my guess, and it's asking for less, and I'm saying, okay, 98. No, I'm always taking the middle point of the information I have. Okay, so we guessed the number. Now let's go and see how this stuff is working. Of course, we included the random generator library. You have the implementation, the corresponding implementation here. You don't have to know how it's working, you just have to know what it is doing. Here, an explanation is given why we need 7 steps to find numbers from 1 to 100, 7 guesses. Okay, and this is very important, because as an engineer, you should come up with formulas and not just, okay, let's do it like this. You should precisely know what you're doing. So the number of steps is 7, because the logarithm with base 2 of 100 is 6 point something, and the ceiling of that is 7. We define a new random generator, which is called RandGen. This is a variable. And this is the random number, okay? We print, I know a number between 1 and 100, can you guess it? And we define a Boolean variable called found. Initially it's false, because we didn't find the number. Okay, we didn't correctly guess it. Now that random number is going to be the following. Random generator, RandInt. You remember the RandInt function that we wrote on the board? It basically returns a random number between 1 and 100. And this integer number is going to be given to the random number here that we defined. Now we start from 1 to step I++. Of course, if the number is found, we don't want to go to loop it again and again, okay? That's why we say if the number of steps is smaller and the number is not found, then go inside. But initially, let's start. So initially, we start with 0, meaning the first guess, and we keep the number of guesses here. I mean, the guess we are giving. So we're printing guess 0 is which one? And I'm reading, okay, the guess is Or better, let's go from scratch. So I'm here now. Let me enlarge the font. So I know a number between 1 and 1. Can you guess it? I'm printing it. Okay. Now I'm here. I is 0. Okay. So I'm going inside. And I'm expecting a guess. And let's say I give a guess as 50. And I press enter. Okay. When I press enter, I have the number, the guess. I don't know what's the guess. If you want, we can do something like this, even better. Let's start from scratch. So I'm running the program, and I'm here. Okay. You see the variables. Initially, they are not initialized. So let's go debug. Step over. We define a new random generator. Debug. Step over. Then we are printing debug. Step over. I know a number between 1 and 100. So I just printed this stuff. I'm not going to write on board. I'm just going to run the program. Now I'm saying that bool is false. Being initially found, it was true, but now found is going to be initialized to false. So step over. You see false is in red because we just initialize it. Now random number, this is important. The random number has no value, has something that makes no sense for the time being. But in this step, I'm going to assign to the random number a real random number between 1 and 100. And I'm going to use this RandGen variable from RandGen class. So step over. You see that the random number that I just generated is 81. It's in red. Now I'm going inside the for loop and I define I inside of it. So debug, step over. I initially is 0. Now I'm about to print this guy here, guess 0, meaning the first guess. We start numbering, counting from 0. And the compiler now, we are here, expects a guess from me. Let's say I'm giving 50. Okay. Now 50, if the 50 is equal to the number, then found is going to be true, but it's not the case. That's why we are going here. This is false. So we are going to be the else clause. If the guess is greater than the random number, and the guess was 81, and the number was 15, so what do you think? Is this guy going to be printed? So if I go debug, step over, I'm going here. Now guess is 50, and the random number is 81, as you can see. Are they the same or not? So guess is 50, and this is 1. Is this true? No. That's why debug, step over. I'm going here, and this else for sure is going to be executed. I'm printing bigger please, so we should see bigger please here. So debug, step over, and I'm seeing bigger please. Now we go to the beginning of the loop, and we check this part here. I is smaller than steps. Steps is 7, and I is going to, we increment I, of course, so debug, step over. I become 1, okay. And we are checking whether I is smaller than steps. This is true, since 0 is smaller than 7. And the value of found is false. The negation of false is true. So if the number of steps, this is smaller, if I is smaller than steps, this is true. And this is true, even it's not found, then go inside. Meaning if we have not reached 7 steps and we have not found it, go inside. We are going inside and we are giving the guesses, okay? Again, guess this is, I should print now guess 1, step over. Let me guess it correctly, right? Oh no, let me give 75. So debug, step over. 75 is my guess. I'm giving it as a guess. And I'm checking whether it's equal to the random number. No, it's not. If the guess is greater than the random number, so guess is 75, our guess, and the random number is 81. And this is not true again. So debug, step over, bigger please. We should get this message. Now I'm going to cheat because I'm going to give 81 as an input. So step over. I is going to be incremented by 1. From 1 is going to be 2. And we check this stuff here. This is again going to be true. if this is true, we go inside. So debug, step over. We are asking for the guess. And I'm giving the guess 81. I'm going to cheat basically, since I know that it's 81. So step over, 81. When I press enter, guess is equal to random number. It's 81, this guy in red, equal to random number, which is 81. So yes, if this is yes, found is going to be true. So debug, step over, found is going to be true. And we are not going to check those other else's. Basically, we are going in the beginning. We are going to increment I by 1. Okay. And we are going to check this condition here. So 2 is smaller than steps. This is true. And we have an AND clause here. And I say that found is true. Negation of true is false. Basically, I have something like true and false. The overall value of this expression here is going to be false. Okay. Since this is false, I'm over with the for loop. So I go here and I print this stuff here. Okay. So I'm over with the for loop. Step over. That's why I go to if not found. Okay, so found is true, not found is false. So this is not going to be executed. Meaning I'm saying if I haven't found the guess, then the random number, then I should print sorry you couldn't find it. Otherwise, debug, step over. Since found is true, negation is false, meaning that this else is going to be executed, I should print congratulations, you have found the number. So debug, step over. I should have this, congratulations, you have found the number, and I'm finished. Okay? Is this clear? Questions? Okay. If you don't have any question, then we might continue with some other stuff, just like 5 minutes, when I'll give you the break. This is about the polynomials. Okay, not the polynomials. Okay, the polynomial. Let's do some calculus stuff. You have seen the quadratic functions, probably. So I'm saying it again. I'm going to do some theoretical part here, and we are going to solve the program afterwards. Because I think you can understand the program much better. We do something like this on board, and then we go through the program. So, quadratic functions. Have you heard about quadratic functions? Of course. You have seen them, I suppose, in high school as well. How do they look like? Do you know what a quadratic function is initially? I know you know it. Maybe you cannot recall it right now. But let me remind you. If you have something like this, y is equal to ax squared plus bx plus c, where a, b, and c are real numbers, and a is not equal to 0, then this is a quadratic function. So let this guy be our first equation. Now, what's the most simplest quadratic function? It's y equals to x squared. If we draw this guy, meaning b and c are 0, the coefficients. If we draw this guy, we will have something like this. Okay, so this is y equals to x squared. What's the name of this graph? It's parabola, yes. But let's draw another parabola like this. So what's going to be the difference between this parabola and the other one? Yeah, it will be turned upside down. Okay? I'm not a good writer, so this is not a curve, this is a parabola. So this is y is equal to minus x squared. Now, parabolas have extreme points, meaning the lowest, the point with the highest value, and the points with the smallest value. Those are called extreme values. This parabola has a minimum. This is the smallest value the y can have. Okay, so this is minimum. But this parabola here has a maximum. And it's here. Both of them are in 0, 0. But it's not always 0, 0 because we can have other values for a, b, and c. So our problem is the following. We are going to generate random coefficients for a, b, and c. And our job will be to find those extreme values, find x, find y of those extreme values, and find whether it's a minimum or maximum. How are we going to do that? Any clues? How do we find extreme values? Do you remember it? The derivative. Exactly. So we're going to take the derivative, I write it like this, with respect to x, and the derivative of y, so yes, is going to be 2ax plus b, and the derivative of a constant is 0. So I'm taking it with respect to x. And I should make it to be equal with 0, okay? So what's the value of x? X is equal to minus b over 2a. Okay. So this is our second formula. We found that x, this is the extreme values, meaning maximum or minimum. How can we find y? Y is equal to, I'm not going to write the formula, just put these two to 1, okay? Change the value. We are going to find x, and just substitute this value to the first equation. Okay, so we got it. Basically, we should find this stuff. ax squared plus bx plus c. Now, the third job is the following. We should see whether it's a maximum or a minimum. So how are we going to do that? Do you have any clues? Do you remember it or not? You find the second derivative. And if it's what? Okay, the second derivative with respect to x is equal to 2a. Is that 2a? Yeah. Okay, if the second derivative is greater than 0, we have a minimum. Exactly. Okay. So 2a is greater than 0, but 2 is always greater than 0, meaning that a should be greater than 0. If a is greater than 0, basically the parabola is turned like this, okay? So we have a minimum. Otherwise, if a is smaller than 0, we have a maximum. So 1, 2, 3, 4, 5. Where are we going to need those 5 guys, 5 formulas, in order to find the extreme points of and the corresponding coordinate of x and y, and find whether that extreme point is a minimum or a maximum. Okay? I'll give you a break of like 5 minutes and we will be back. Okay?